Right, this is the 2015 Geometry External. We're up to question 2. Regular pentagon with centre O. Find the value of x. Now, x is an external angle, and if we were to extend each side, each of the 5 sides, and draw in each of the 5 exterior angles, they would all sum up to 360. So x is just going to be 360 divided by 5, which is 72 degrees, and the reason is exterior angles of a regular pentagon sum 360 degrees. Right, find the value of y. Well, for this one we might work out the centre angle. Now remember it's regular, so angle COD will equal 360 divided by 5, which is 72, and that's because angle's at a point. So 360, and it's a regular pentagon. Right, and now because it's regular, those two lengths will be the same, so I actually have an isosceles triangle. So to work out y, it'll be 180 minus 72. We need to halve that, which gives us 54 degrees, and that's because of base angles. An isosceles triangle are equal. Right, now we've moved on to a circle question. I'm told that BOC is a diameter. I'm told that QCP is a tangent. Find the size of angle ACO, so that's that one down there. So I know that angle OCP is going to equal 90 degrees because a tangent is perpendicular to a radius, which means that angle ACO is going to equal 90 minus 40, which will be 50 degrees. Right, and without losing the picture, it says find the size of angle OAB, so that's that one in there. Now these are all radiuses, so it means there's some isosceles triangles in there. When we're dealing with circles, the other things we need to be looking for are arrowheads, butterflies. We've already talked about isosceles triangles. The angle in a semicircle being 90 degrees, and actually that one might work there because that's 50, and angle BAC is an angle in the semicircle. So we'll write angle BAC equals 90 degrees, and that's angle in a semicircle. We'll once again say that angle OAC equals 50 degrees, and that's base angles in an isosceles triangle are equal. And that means that angle OAB that we're trying to find will be 90 minus 50, which is 40 degrees. Right, part 3. We're told some information over here. OL is x centimetres, LOM is A degrees. Calculate the length of NL in terms of x and y. Well, we'll call this x and a, so we'll call this y. That's what we're looking for. Now there's some isosceles triangles in here. If that's a radius and it's x centimetres, then that's x centimetres as well, and that must be x centimetres as well. So we'll just explain that length NM equals 2x, and that's because of radiuses. Right, so actually what I have is a triangle that looks like this. That side is 2x, that's y. And it's y that we're trying to find the value of. To be able to use trigonometry, it would be good to have a side, an angle, sorry, either the top one or the bottom one. I can see that knowing that's A, I could actually work out this bottom one down here, because this is an isosceles triangle. So angle LMO, to find that one there, would be 180 minus A, and we'd divide that by 2, and that would give me that angle in there. So that angle is 180 minus A over 2. Now I have the opposite side, I have the hypotenuse, so I can see that sine of equals SO, opposite, over hypotenuse, and therefore to work out y we'd need to multiply by 2x on the other side. There's other ways you can do this problem as well, but there's one way with a satisfactory answer. Right, there's one more problem on this question, quite a complicated one, so we'll just take our time reading the question. Prove that YR equals RZ. YR equals RZ. Right, we want to prove those two things are equal. Quite tricky. What would be easier to do actually is to prove that SR and RZ are equal. If I could show that those two were equal, then that would mean I could put a blip on RZ, which would mean it's the same as RY. So in one way to show that SR and RZ are equal would be to show that the angle RSZ and SZR are equal, because then it would be an isosceles triangle. The two sides would be the same, and hence those two would be the same. So I've got my goal. I want to show that SR is equal to RZ, because that will mean SR equals RY, which must equal RZ, which is what I'm heading for. So we need to find some angles. Now YZ is a tangent, so straight away I've got a 90-degree angle in there. And that's because the tangent meets the radius. Right, so that's 90. Now using the big triangle, I can see that angle SZR is going to equal 90 minus x, and that's angles in a triangle, sum 180. Because I've already got 90, there's x, and that one down there must be 90 minus x, so that the three angles altogether add to that. Right, now SR is also a tangent, so that means that angle in there $90. Now we can work out some of these angles around here. You can see I've got an isosceles triangle, so that would make angle XSO equal to x, and that's base angles isosceles triangle are equal, so that would be x. Therefore that one in there must equal 180 minus 90 minus x, which would be the same as 90 minus x. and that's angles on a straight line. And so I've done it because now I've shown that those two angles are the same, which means it's isosceles, so those two, at least isosceles, so those two angles are the same. Sides are the same, sorry, which means it's the same as that. So we'll just finish off by saying, noting that angle RSZ so it could be equilateral, but that doesn't matter because it would prove the same thing. So this shows me that SR is equal to RZ, hence which is what we wanted to prove.